When is enthalpy change zero in a chemical process? Have you ever wondered when the enthalpy change is zero during a chemical process? It might sound complex, but it's quite straightforward once you break it down. Enthalpy change, often represented as delta H, is zero when the potential energy of the reactants matches that of the products. This means that no net heat is absorbed or released throughout the reaction. To understand this better, let's think about enthalpy as a measure of the total heat content in a system, especially when pressure remains constant. It's important to note that enthalpy is a state function. This means it only depends on the initial and final states of the system, not how it got there. So, when a chemical reaction or physical change occurs, and there's no difference in enthalpy between the starting materials and the end products, that's when delta H equals zero. This situation often happens in a few specific scenarios. First, consider physical changes that involve no heat exchange. For example, phase changes like melting or freezing can occur at equilibrium conditions, such as ice melting at 0 degrees Celsius under constant pressure. Here, the heat absorbed equals the heat released, resulting in no change in enthalpy. Another instance is when the reactants and products have identical enthalpies. This means their internal energies and bonding arrangements lead to the same total heat content. Additionally, we have isenthalpic processes. In these cases, the enthalpy remains constant throughout the process. This can occur during certain expansion or throttling processes in thermodynamics. In practical terms, if a reaction does not absorb or releases heat to the surroundings, the enthalpy change is zero. For instance, consider an idealized reversible reaction at equilibrium. Here, delta H equals zero because the forward and reverse reactions happen at the same rate and energy level. Understanding when enthalpy change is zero is essential for analyzing energy flow in chemical reactions and physical processes. It helps determine if a process is energetically neutral or involves heat exchange. This concept is fundamental in thermodynamics and aids in predicting how reactions behave and in designing energy-efficient chemical processes.